Hello everyone, welcome to my YouTube channel. On this channel, I will be providing detailed and structured lecture for b.tech Biotechnology students, especially according to the executive syllabus. In this lecture series, I will start with the bioprocess engineering and will cover all the units step by step. Today we will discuss an important fundamental concept in science and engineering, that is conversion of unit and dimensions. So first let us understand what a unit is. A unit is a definite magnitude of a physical quantity that it uses as a standard for measurement. Whenever we measure or count something, the result consists of two parts, that is a numerical value and a unit. For example, 5 meters, 10 kilometers, 2 seconds. Here 5, 10 and 2 are numerical values and meter, kilogram and seconds are units. A measured quantity must always be expressed in terms of an appropriate unit having the correct dimensions. In scientific and engineering calculations, we often need to express a quantity from one unit into another equivalent unit. For example, converting kilogram to gram, converting inches to centimeter, and converting pounds to grams. To do this, we use something called a conversion factor. So let us understand a conversion factor is defined as a ratio of equivalent value of a quantity expressed in different units. It is always equal to 1 because it represents the same quantity written in two different units. For example, 1 kilogram equal to 1000 grams. Here 1000 is the conversion factor between kilogram and gram. Now let's see second example. 1 inch equal to 2.54 centimeter. Here 2.54 is the conversion factor between inch and centimeter, and 1 lb equal to 453.6 gram. For each conversion factor, we can derive a unit bracket. For each conversion factor, we can derive a unit bracket that equal to 1. For example, if 1 lb equal to 453.6 gram, then the following ratio are equal to 1. 453.6 gram upon 1 lb equal to 1, or we can say 1 lb upon 453.6 gram equal to 1. Since these ratios equal 1, multiplying any quantity by them does not change the value. It only changes the unit. Convert 2 lb into grams. 2 lb into 453.6 gram upon 1 lb. Value is 907.2 gram. Here lb cancel out and we get the result in grams. This is the standard scientific method for unit conversion. Now let us understand the concept of dimensions. Base quantities are called dimensions. Example of base dimensions are length, mass, time. These are fundamental quantities. For example, length and time are dimensions. Mass is also a dimension. Next, we will move to the system of units. A system of units provide a standard method for measuring physical quantities. There are two commonly used systems. First, SI system, also called International System of Unit. Second is CGS system, centimeter, gram, second system. The SI system is globally accepted standard system. Now, classification of units. Units are classified into fundamental base units. These are independent units that cannot be derived from other units. There are 7 fundamental units in SI system. First, length. SI unit is meter and symbol m. Next, mass, SI unit, kilogram, symbols kg. Next is time, SI unit is second, represent S. Next is temperature, SI unit is Kelvin, represent K. Electric current, SI unit is ampere, symbol A. Amount of substance, SI unit mole, symbol mole. Luminous intensity, SI unit candela, symbol CT, small ct. Now, derived units. Derived units are obtained by multiplying or dividing base units. For example, speed equal to distance upon time. Another example, force equal to mass into acceleration, and pressure equal to force upon area. Some important derived quantities are volume. Now let's see the conversion of units. For example, force. According to the Newton's law, the force exerted on a body in motion is proportional to its mass multiplying by acceleration, that is F equal to m into a, where F is force, m is mass and a is acceleration. So SI unit of force is Newton, and 1 Newton equal to 1 kilogram meter per second square. In CG system, 1 Dalton equal to 1 gram centimeter per second square. Now another example is pressure. Pressure is defined as force per unit area, that is P equal to F upon A, and 1 Pascal equal to 1 Newton per meter square, and the dimension is m L power minus 1 T power minus 2. Now next is density. Density is defined as mass per unit volume. Rho equal to m upon V, and the unit will be kilogram per meter cube in SI system and gram per centimeter cube in CG system, and the dimension is ml power minus 3. Density of liquid and gases depends on temperature and pressure. Next is specific gravity. Specific gravity is also known as relative density. As the dimensionless variable, it is the ratio of two densities, that of a substance in questions and that of a specific reference material. For liquid and the solid, the reference material is usually water. For gas, air is commonly used as the reference material. So the formula is specific gravity equal to density of substance upon density of water. Now specific volume. Specific volume is the inverse of density. So specific volume equal to V upon M, or we can say 1 upon rho, or density. Now let's see chemical composition terms in bioprocess engineering. Some chemical composition terms in bioprocess engineering is expressed in different ways. So let's see what will be the terms. And the process streams usually consist of a mixture of a component or solution of one or more solutes. So the following terms are used to define the composition of mixtures and the solutions. So the first is mole fraction. The mole fraction of component A in a mixture is defined as mole fraction of A equal to moles of A upon total number of moles. Now second will be the mass fraction. The mass fraction of component A in a mixture is defined as mass fraction of A equal to mass of A upon total mass. Next is volume fraction. Volume fraction of a component A in a mixture is volume fraction A equal to volume of A upon total volume. If we need to calculate in the percentage forms, so mole percentage equal to mole fraction into 100 and mass percentage equal to mass fraction into 100 and volume percentage equal to volume fraction into 100. Mole concept. A mole is the amount of substance containing Avogadro numbers of particles. 1 mole equal to 6.022 into 10 power 23 particles. This number is called Avogadro number. Mass mole relationship will be the number of moles equal to mass of substance upon molecular weight, or N equal to M upon capital M, या molecular weight, where small n equal to number of moles, M equal to mass, capital M equal to molar mass. Next is temperature scale. Temperature indicates the thermal energy of a body. Some common scales are Celsius, Kelvins, Fahrenheit and Rankine. Kelvin is the SI unit of temperature and some conversions are shown on the display. The next is weight. Weight is the force exerted on gravity on the body. So W equal to M into G, where G equal to 9.8066 meter per second square. Weight depends on gravitational acceleration. So these concepts are fundamental for solving numerical problems in bioprocess engineering calculation. So if you want, I'll provide numerical examples. So just tell me in the comment, and thank you.